All right, so are you ready to dive into some seriously mind-bending cosmology?
Always ready.
We got a fascinating article sent in about the JWST, and let me tell you what this telescope is seeing is making scientists rethink pretty much everything we thought we knew about the universe.
It is really pushing the boundaries of our understanding.
I mean, we're actually talking about the possibility that our entire universe exists inside a black hole.
Yeah, it's a pretty wild concept.
It's a wild one, but before we get into like the whole black hole thing, can you break down exactly what the JWST is observing that's causing all this buzz?
Absolutely. So the JWST has been looking at the rotation of galaxies way out there in the early universe billions of years ago. And what's really strange is that it's found a preferred direction of spin.
A preferred direction.
Yeah, so out of the 263 galaxies they've observed, about two-thirds of them are rotating clockwise, and only about a third are rotating counter-clockwise.
Okay, and why is that such a big deal? Why wouldn't they just be spinning randomly in all different directions?
Well, in a truly random universe, you'd expect a 50-50 split, right? Like flipping a coin.
Right.
So this preference for clockwise rotation really suggests that something else is going on, some kind of underlying force or structure that we don't fully understand.
Okay, so that's where this whole black hole cosmology theory comes in.
Precisely. Some scientists think this preferred spin direction could be evidence that our universe exists inside this giant rotating black hole.
Inside a black hole?
Yeah, situated within an even larger parent universe.
Okay, hold on a sec. I thought black holes were these, like, all-consuming monsters that crushed everything that got too close.
Yeah.
But how could a whole universe exist inside one?
Well, it all comes down to understanding the concept of the event horizon,
Okay.
that boundary around a black hole where nothing, not even light, can escape. Black hole cosmology proposes that what we perceive as the edge of our observable universe is actually the event horizon of this massive black hole we're in.
I'm trying to wrap my head around that. So are you saying that every black hole that we observe in our universe could potentially be another universe?
That's one of the mind-boggling implications of this theory. Each black hole could be like a gateway to a separate baby universe completely cut off from us by its own event horizon.
Wow, universes inside universes, inside universes. It's giving me a headache.
It's a pretty dizzying thought.
It is. All right, so let's try to bring it back to the JWST and the spinning galaxies. How does that observation actually connect to this whole black hole theory?
Well, the idea is that if our universe was born inside a spinning black hole, the spin of that parent black hole could have influenced the direction of spin for the galaxies within it.
Oh, I see, like a cosmic inheritance passing down that spin from parent to child?
Yeah, that's the general idea.
Okay, so you're saying the reason these early galaxies are mostly spinning the same way is because the parent black hole was also spinning that way.
That's the thinking.
Yeah.
And there's this one physicist, Nikodym Poplawski, who's really been a champion of this theory.
Okay, so let's hear about Poplawski. What's his take on this?
Well, he's got some really fascinating ideas about how it all works,
Okay.
particularly regarding black holes and the Big Bang.
Yeah, the Big Bang, isn't that supposed to be the beginning of everything? How does that fit into this?
Well, Poplawski's theory actually suggests that the Big Bang might not be the absolute beginning.
Oh, really?
He argues that inside a black hole, the forces are so strong, particularly something called torsion, which is kind of like the twisting of space-time,
Yeah.
that would actually prevent matter from collapsing into a singularity.
Torsion. That sounds intense. So what happens to the matter instead of being crushed into nothingness?
Poplawski thinks that matter bounces back, almost like a super compressed spring, suddenly releasing all its stored energy. And he proposes that this bounce back could actually be the driving force behind the rapid expansion that we call the Big Bang.
So the Big Bang wasn't the beginning of everything, but rather just the beginning of our universe inside this black hole.
That's what Poplawski is suggesting. He even goes on to propose that our universe's arrow of time, the direction that time flows, might actually be inherited from the parent universe through this bounce-back process.
Okay, so that's a pretty huge shift in perspective. I mean, if that's true, it really kind of flips our understanding of the universe on its head.
Yeah, it's definitely a radical idea, but I'm guessing not everyone in the scientific community is fully on board with this whole black hole cosmology thing, right?
You're probably right. So what are some of the other explanations out there for the JWST's observations? Is there anything else that could explain this whole galaxy spin pattern?
Well, one of the leading alternative explanations is that our own Milky Way galaxy's rotation could be skewing what the JWST is seeing.
Our galaxy. How could our galaxy spin mess with observations of galaxies that are billions of light years away?
Well, it all boils down to how we measure distances in space. If the Milky Way's rotation is influencing our measurements, it's possible that we've been miscalculating the distances to those faraway galaxies.
So if the distances are off, then what kind of impact would that have?
Well, for one thing, it could mean we need to recalibrate our entire cosmic yardstick, so to speak.
Our cosmic yardstick?
Yeah, and that could have major implications for our understanding of how fast the universe is expanding and even the age of some of the oldest galaxies out there.
Okay, so let me get this straight. We've got this observation of galaxies spinning in a preferred direction, and it could either be evidence that we're living inside a giant black hole, or it could mean that we need to completely rethink how we measure the universe.
You got it. It's a pretty exciting dilemma.
It's a big one. So which is it? Are we in a black hole? Or do we need to fix our cosmic ruler?
Well, that's the million-dollar question, and the JWST has certainly opened up a whole new can of cosmic worms.
It definitely has, and we're going to need a bigger can. So tell me more about this alternative explanation. What are the implications of having to recalibrate our cosmic measurements? How would that change our understanding of the universe?
Well, that's a great question, and that's what we're going to be diving into next.
So, okay, let's dig into this idea that our own Milky Way's rotation is messing with our measurements. If that's true, wouldn't that mean like rethinking a ton of what we thought we knew about the universe?
Absolutely. If our cosmic yardstick needs adjusting, it really impacts some pretty fundamental things in cosmology, like the rate at which the universe is expanding.
Oh, yeah, I remember reading about that. There was some controversy around that whole expansion rate thing, right? The Hubble tension.
That's exactly what I'm talking about. So basically, scientists have been using different methods to measure how fast the universe is expanding, and they're getting different answers. That discrepancy, that's the Hubble tension.
So if our distance measurements to these faraway galaxies are wrong because of the Milky Way spin, could that actually solve the Hubble tension?
It's definitely a possibility. If our distances are off, then recalibrating those measurements could bring those different expansion rates into alignment, solving the Hubble tension and giving us a more accurate picture of how the universe is evolving.
That would be huge. It would mean our current models of the universe aren't completely wrong. Just need a bit of tweaking.
Yeah.
You also mentioned that this recalibration thing could affect how we think about the age of galaxies too, right?
Yeah, that's another piece of this puzzle. So the JWST has seen some incredibly distant galaxies, and based on our current calculations, they seem to be older than the estimated age of the universe.
Older than the universe? How is that even possible?
Well, it wouldn't be, at least not according to our current understanding of cosmology. It's a bit of a paradox, but it's one that could potentially be explained by these inaccurate distance measurements. If those galaxies are actually closer than we think, they wouldn't have to be as old to appear the way they do.
So by adjusting the distances we could make, the age of these ancient galaxies fit within the established timeline of the universe.
Precisely. Recalibrating our cosmic ruler could resolve this apparent paradox and bring those galaxies' ages into line with what we know about the Big Bang and the early universe.
Okay, but honestly, how likely is it that the Milky Way's rotation is really causing all these measurement issues? It seems almost too simple.
It's a fair question, and scientists are still actively investigating this. It's not a sure thing, but if it turns out to be true, it'd have a huge impact. We might have to go back and revise some of our most fundamental assumptions about the universe.
And if it's not the Milky Way's rotation, are we back to that crazy idea that our universe is inside a black hole?
That's right. We'd be back to dealing with black hole cosmology and the whole universe within a universe within a universe thing.
I have to say, it's both terrifying and exhilarating. The thought that everything we know, our entire universe, is maybe just a tiny pocket within a vast multiverse of other universes, each one potentially born inside its own black hole, it's hard to even grasp.
It really challenges your perspective, doesn't it? And it raises a lot of philosophical questions about the nature of reality and our place in it all.
It does. So where do we go from here? How do we figure out which of these explanations is more likely?
More research, of course. Scientists will keep looking at the JWST data, searching for more evidence of this preferred direction of galactic rotation. And they'll be studying the Milky Way's rotation more closely, trying to determine if it really could be the culprit behind these skewed measurements.
So more data, better models, and seeing where the evidence leads?
Exactly. And who knows what other surprises the universe has in store for us as we keep exploring.
Speaking of surprises, this whole discussion has been a huge eye-opener. I knew the JWST was powerful, but I never imagined it would lead to questions like, are we living in a black hole?
It really speaks to the power of science and exploration. The more we learn, the more we realize how much we still don't know. And that's what makes it so exciting.
It is. Okay, so before we move on, let's do a quick recap.
Yeah.
We started with the JWST's observation that many early galaxies seem to be spinning in the same direction.
An observation that goes against what we'd expect in a random universe and hints at some deeper order or influence at play.
Right. And to explain this observation, we looked at two main possibilities. First, that our universe is inside a rotating black hole, and its spin is affecting the rotation of the galaxies within it.
That's based on black hole cosmology, where each black hole could be a gateway to another universe.
Yeah.
A fascinating but still very speculative theory.
And the second possibility is that our own Milky Way's rotation is distorting our measurements of distant galaxies, potentially explaining both the galaxy spin pattern and other cosmological puzzles like the Hubble tension.
And solving the Hubble tension would have significant implications for our understanding of the universe's evolution.
Right. So we're left with these two totally different but equally mind-blowing possibilities. Either we're living in a cosmic nesting doll of black holes and baby universes, or we need to seriously rethink how we measure the universe.
It's a fascinating dilemma, and both options are still very much on the table.
It definitely keeps things interesting. You know, it's amazing to think that something as seemingly simple as the direction galaxies spin could lead to such deep questions about the nature of reality.
It just goes to show that the universe is full of surprises. And even the most basic observations can lead to groundbreaking discoveries.
Well, this has been an incredible deep dive so far. I'm sure you, our listener, are probably full of questions and thoughts right now. Let's shift gears a bit and think about the philosophical implications of all this. What would it really mean for us if we discovered that our universe is just one of many inside a black hole?
Yeah, it really makes you think, huh? If our universe is just one of many tucked away inside a black hole,
Yeah.
does that make our existence less significant? Does it change anything?
Well, it definitely challenges our perspective. On the one hand, it could make our universe seem small, right? Like just a tiny speck in this vast multiverse. But then again, it opens up so many possibilities. The universe could be even more complex and amazing than we ever imagined.
It's kind of like that moment when we realized the Earth wasn't the center of the solar system. It's humbling, but also kind of exciting.
Exactly. And think about the laws of physics. If our universe is inside another one with maybe different physical laws, it could completely change how we understand reality. It really blows your mind. It makes you wonder what else is out there that we can't even comprehend.
It's awe-inspiring, isn't it? It reminds us that we've only just begun to understand the cosmos.
And maybe that's okay. Maybe the most important thing is to just keep asking these big questions, to keep exploring and pushing the boundaries of what we know.
I completely agree. The journey is just as important as the destination. Maybe even more so.
Well said. Well, I think that about wraps up our deep dive for today. We've covered some seriously mind-blowing ideas, from the incredible observations of the JWST to the possibility that our universe is inside a giant black hole.
It's been a wild ride for sure.
It really has. And who knows what other amazing discoveries are waiting for us out there.
The universe is full of surprises.
It certainly is. So to our listener, we'll leave you with this final thought. If our universe is just one tiny part of a much larger multiverse, does that change how you see your place in it all?
Keep looking up and keep those questions coming.
And that's it for this episode of The Deep Dive. We'll see you next time for another deep dive into the most fascinating corners of science and technology. Until then, stay curious.